Now can you hear me?
Yes.
All right, so next speaker is Joshua Dunfield, and the talk is about elaborating evaluation order polymorphism.
All right, thanks. So ICFP is back in Canada, which is great. This is the only paper from Canada that got in, so I guess we need to do better here. So the Algol 60 committee met in Paris and had many good ideas and some bad ideas. Invented call by name, decided that Algol should have both call by name and call by value arguments. Everyone flew home. And the editor of the report decided that call by name should be the default and call by value should be the funny one that you have to put in the extra keyword for. And he later said this is one of a few matters of detail that he had to resolve in writing the report. Not everyone agreed with this. So one of the committee members, again a few years later, said, well, there was nothing one could do. It had to be swallowed for the sake of loyalty. And you thought language design arguments now were bad. And ever since, the community has been divided by which evaluation order is clearly better and whose front yard is the right front yard. These are two cats in Vancouver who don't get along very well. The funny thing is that even though people think their evaluation order is clearly the right one most of the time, sometimes you want the other one. So Haskell has strictness annotations when you don't want laziness. Standard Mill of New Jersey has a lazy keyword when you do want laziness, and Scala has a func thing you can put on arguments. So I'm not a social scientist, so that most social science at ICFP is probably fake. Programmers tend to choose a language based on what evaluation order they like, and then they tend to solve the problems suited to that language, which suited to that language's evaluation order, which confirms their opinion about that evaluation order being better. So I'd like to suggest that the question, which evaluation order should your language have, should maybe be treated the same way you might react to this question, and that maybe the answer should be both, and they should both be easy to use. Someone said JavaScript, I think. So, try to do is design a language that is unbiased about evaluation order. And the story that I've told many times in the past, entire time as a grad student, is you want typing so you can keep out the bad programs. But you can also use types to give you more programs or more elaborations of a single program. And so what I did in this paper is I don't want to duplicate the terms because then you just end up with call by value lambda, call by name lambda, and you have to write that everywhere. So instead we'll duplicate the types. So there'll be two arrows, call by value, call by name, two products, and so on. And this is the most interesting part, there will be polymorphism over evaluation order. So you can write one function once and get both call by value and call by name versions. So this paper has three type systems, which, depending on your view about types, is either 3 too many or 2 too many. The one on the right is not very interesting, fortunately. I will mostly talk about the one on the left. And you can read all of them in the paper. So in the impartial type system, I'm not trying to choose favorites of which evaluation order is better. So it has both versions of all the standard connectives and polymorphism. Then that's too many connectives. I was Frank Fenning's student, so you always want fewer things. So we'll abstract over the differences between the call by value connectives and the call by name connectives by stuffing it all into this suspension type, which is either nothing or it has a func. Then you erase types, so that usually happens, and you get a target language which is just call by value with a thung type. But you can think of that as just unit arrow A. The only point I want to make here is that this is just ordinary syntax, right? I don't have evaluation order in the terms here. So all the expression forms work for both versions of the connectives. Type system is where it gets interesting. Evaluation orders epsilon are either by value, by name, or one of the variables that you introduce with the evaluation order quantifier, which is a Cyrillic letter. Pronounce it for all. I don't speak Russian, so please don't. No. Then you have epsilons decorating all of the standard connectives. I want to give an example so that even if typing rules make your eyes glaze over, you'll get something out of the talk. So if you do the traditional encoding of ML-style data types into their component connectives, first you get rid of the nullary constructors because they're weird. Then you turn the vertical bar into a sum type. Then you drop the constructor names. Then you replace list alpha with something you bind with a mu. That's all standard. What we'll do is generalize over evaluation orders so that you can instantiate A with either V or N. If you instantiate with V, you get a list. And if you instantiate with N, you get a stream of alpha. You can argue about whether it's a stream because it necessarily terminates. It's a terminable stream. And now you can write map once for both. So the term does not mention evaluation orders. It will get elaborated. And the type of map is polymorphic in evaluation order. Interesting thing about lambda calculus is that type safety holds no matter which evaluation order you have, because you can reduce anywhere. You still have subject reduction. So maybe we can just replace the arrow with the arrow that has the epsilon evaluation order on it, and we'll get something reasonable. The problem here is that the evaluation order is implicit. It's not in the term. So it depends on the particular typing derivation your compiler chooses, and it can choose any epsilon for either of these. I'm giving this talk, so the answer is bidirectional typing. Focusing is pretty cool, too. So the usual why do we want bidirectional typing is about handling things that are undecidable, pure type inference, or for better error messages. Here it's a different motivation. It's to make typing more predictable. So the idea is that we want to organize the flow of information out of type annotations, because annotations express what programmers want. So if you already know tau, you can check it. You can check a term E against tau. If you don't know where you're going, if you don't have a goal in mind, then you synthesize a type for E. And Frank Fenning came up with this recipe, which is introduction rules check, elimination rules synthesize. I won't try to justify that here, but it happens to work out nicely. So now when you introduce an arrow, the type has to come out of some annotation you wrote. When you eliminate it, the type again comes out of some annotation you wrote somewhere, perhaps with its type in the context gamma. Now for polymorphism, you can handle it like for all, which you handle like this. So the introduction rule, it's the usual thing. Introduction rules for universal quantifiers usually don't give you much trouble. It doesn't give you any trouble here. If you're checking E against a polymorphic quantifier, you introduce A as a parameter in the premise. The elimination rule, you synthesize a polymorphic type, and now you need to instantiate A with something. The problem here is that this epsilon, again, it could be V, It could be n. It could be another evaluation order variable. And you don't necessarily know what you want at this point. You can always force some particular evaluation order by putting an annotation around E, but you clearly don't want to do that everywhere. So in practice, you'd probably want some way of setting a lexically scoped default evaluation order. All right, so now you have this idea that you want an economical type system with fewer connectives, which will also be closer to the target language that we're heading towards. So with these types, I've replaced all of the multiple connectives with their call by value versions. And there's this suspension type, epsilon suspend s, where n suspend s adds a func, and v suspend s, it's like you wrote s. And now you encode all of the impartial type connectives as economical types. I just want to talk about one of these, which is that in the arrow, you're adding, if epsilon is n, then you're adding a func around the argument. And if epsilon is v, you get tau 1 or tau 2. These particular choices are justified in the paper. Some of them have more degrees of freedom than others. And now again, you can write map once for both lists and streams. And in fact, the body is exactly the same as in the partial system. All right, so now how do you elaborate this and get something you can run? So we don't really care about how we got the typing derivation at this point. We just want to elaborate it. So I don't care that it's bidirectional now. We'll just erase the types and replace it with a colon. If you're introducing a suspension type, so in elab suspend intro, if you're introducing v suspend, then you just elaborate to the same m you got in the premise. If you're introducing n suspend, you add a func around it. So if you're injecting unit, then you add a func around the injection. And if you have something with func around it, and you want to get 1 plus something, you need to force it. And that's done in elab suspend elim n. If we have polymorphic code, we elaborate it first at m1, first at the type with v for a, gives us m1, and then with n for a, which gives us m2. So you elaborate map to a pair of map v and map n. And if you have something that's a stream, so a list n, then you would project out from map to get the version for streams. Since in this particular case, you can only instantiate it with n, that's the only thing that would work, you don't need to put an annotation around map. All right, so meta theory. If something elaborates to m, and m steps to w, then the erased term in the source system with both by value and by name reductions, whatever you want, that gives you some e prime, which elaborates to w. Also, here's my call by value bias creeping in, probably. If you start with an impartial typing judgment that doesn't have n's in it, then you get an economical judgment that doesn't have n's in it. And when that will give you an m that doesn't have n's. And if you step that, then you don't have any by name reductions in the middle there. A judgment that has polymorphism in it is not n-free because you can instantiate the quantifier with an n. And that works the same way as the subformula property always says. History, I have not much time, so There was a conference on the history of programming languages. The proceedings are entertaining and informative. This work came out of 2 papers that used intersection types. One of them did it in secret because we didn't want to scare anyone, and the other one did it in public because it was about intersection types. I couldn't hide it. I didn't want to. There is currently no implementation. That would be nice to have. I'd like to think this opens up a new part of the design space. That doesn't mean it's a good part of the design space to go to. There is no let in this language, which immediately raises a problem that is let strict or not. This is all for call by name, not the thing that most people want if they don't like call by value, which is call by need. I think that most of this would not change. It's just the part at the end where you get to the target language that would have to work differently. And a bigger question is, could you use something like what's in this paper to resolve other supposedly fundamental differences that split us into 2 different fan clubs so that we can be united against the real enemy? Thank you.
I already regret asking this question, but, well, here it goes. Well, the reason we care about evaluation order if we have effects, right? Because we don't have effects, we have strong normalization that any order would do, right? So the only effect on your calculus is non-termination, right? Which is very, very mild effect, and some people kind of, overlook. So if you add mutation, well, I can answer your last question. And for example, if you add mutation, but one thing that I investigated, if you add delimited continuation shift, right? Type system for shifted call by value is, a very, very standard. It just falls out as CPS transform. So, and it has nice properties, including type inference and everything. And if you look shift and call by name setting, then you don't actually want to look at it. So there is obvious, and then it doesn't cover with your system with polymorphism. It's obviously very different systems. So once you add non-trivial effect, something that actually occurs if you disregard programs, then things become, very, very different. And call by name is just, becomes, unpalatable choice, right? Or, So, but in any way, if you want to investigate, of course you should, but, but at least my advice is to add some effects which is more interesting than non-termination, like mutation and so forth, right? And then try to see how that actually works.
I'll just add to that Matthias Verleisen always likes to say that with one effect you can't tell anything. You need at least 2 effects for make this right?
Okay. The only thing I would like to say in response to that is I didn't mention it because I didn't have time. The system does have a value restriction, and it is an interesting value restriction because whether something is a value depends on what type it has. If you introduce a force, then it's not a value. So that is in the paper, so it may take one small step in some direction. But I take your point.
Mutation would be actually that, adding mutation, adding your reference cells, that should be the next.
My question has just been asked, I think. But, you started with ML versus Haskell, and, ML combines call by value and impure. So you probably wouldn't want either call by need or call by name with impurity, would you?
Maybe not. I don't know if this is a good idea, but this is something that I hadn't seen anywhere, and so I thought, well, maybe this makes sense.
Thank you for a nice talk. Nice work. I'd like to ask about the target language. Have you thought about call by push value? It's a bit more neutral.
I originally tried to target call by push value because one of my collaborators is Paul Levy's biggest fan, I guess. I could not make it work. So he has Paul Levy's thesis has 2 perfectly good translations from CBE, from CBN individually. There is no single translation from both. So I'm pretty sure it's possible. I don't know if it's nice.
Is this something you're interested in?
somewhat. I tried to do it and I couldn't. So if someone else would like to do it, that would be great.
Okay, so while Tillman sets up, we can take one more question.
Something very basic I did not understand. When you elaborate polymorphism into a pair, can it happen that the call by value pair loops? Can you have a